And keep your lids up too, because I want to show you something about the lid in a minute. But you have a power supply inside. The light should be amber, should be on, but it's still light. Okay, now looking at the back of your lid, you'll see that your red terminals and your black terminals are linked together. Okay, with a bar. Okay, they're soldered. That's what's called a bus or a bus bar. So I bring that out to the students because they're going to hear about buses all the time. All right. Everything over here is hot, 12. Everything over here is ground. Okay? And you can plug in any one of those to get power, any one to get ground. So I explain that to the students. Okay? What I do is I take a spin around the dial and we talk about, you know, the icons for DC versus AC.
I'm guessing.
Okay?
That's for testing the 9-volt bat. I mean,
and there's a real good reason for doing that, diagnostically speaking, because the engineers today are using AC and DC voltage on the same wire at the same time. Okay, and I'll explain that one to you here. It's really cool. Okay, now switch your meters over to diode mode. Now each meter is different. Some it's a two-step function. You're going to rotate it to the diode symbol on the dial, but then you might have a blue button that has a diode indicator, and you want to push that, and then you get a little diode icon in the window.
you hitting a blue button there?
Okay, so what is a diode?
It's a little thing like when you go to the way valve.
Okay, now go the other way. Nope, it's working.
Oh, that's weird.
So maybe your meter, huh?
Try that one.
Oh, do you have to push the button on that one?
Touch it. I touch the lid.
Oh, you're not in diode mode. See the little icon? There's that. But remember I said on these.
Oh, okay, okay.
See that diode mode
Yeah,
right
yeah,
there?
okay.
Now watch what happens when you push it. All right.
Got your own.
When I reverse it, you should get what? 0.53, 0.52. Okay. Is that what you get? 0.5, 0.6. Fine. Okay. So let me ask you this. Yeah, that's the difference. So let me ask you a critical question. Did you see the resistors I put in there? Okay. All right. So what is source voltage?
13.9.
Okay, 13.9. Huh?
Depends on what meter you trust.
Pretty close.
Yeah.
My
You know, good point here, guys. We got a $500 meter against a $30 meter. Two different readings for voltage.
How much
Okay.
though? What's percentage?
Not really a lot, not worth mentioning, but in here, 1406 on the fluke, 14.23. So it's roughly 0.23 volts. So that's a quarter of a volt. Okay? I think that's a lot. Okay?
You guys seen these before at your schools?
Yeah, I found one in my. They'll have one in my. I'm wondering if the power supply's not bad or something that's stuffed in a closet all sideways.
Probably, yeah.
But I'm hoping. I was curious about it because it looks awesome. It's a very visual, and like I said, a lot of my students, you know, that's even the thing with me with water pressure. I've mocked up a few. Like here's an 8-inch pipe. Even though it's got more volume, it has a low pressure. You know, I try to illustrate that.
Okay.
And
Y'all good on light bulbs?
This is a
Okay,
great visual way to.
Yeah.
Okay. So, you guys never, ever want your students to build an electrical circuit without a fuse.
I'm kidding.
Okay.
That's what I was just kidding about.
Yeah. Okay. So there
That's
should
where
be
your
a
power
fuse.
supply went.
That's why I told him I have one of these. I think my power supply is
These are the
busted.
fuses right
And
there.
I think that's where mine went.
Okay. There's your switch.
I think my power supply went to that. I think they built it without a fuse.
That's what happens. Okay, so this you can just stick right up here somewhere, and then come right in here, and then from here to here, leapfrog, and then over to ground. Backwards. Normally what I do at this point is I don't have the students power anything up. I just have them leave it off. It's too late now. Because here's what I do. I have them measure circuit resistance through R1, R2, and R3, and then record it cold. And I tell them. Okay. Why do you think those heat sinks are on there?
It's a lot of heat to wick it out to cool it.
Yeah, it's basically a radiator that's like a Volkswagen. It's an air-cooled source, right? So those fingers are pulling the cool air from the environment and cooling that power transistor down, because those puppies get so damn hot you can actually fry an egg on them. which is why if you look at this computer, you'll see there's power transistors, same one you have on that board right there, identical, okay? And you'll see that they're bolted to the side here, and they're bolted here with some silicone paste in behind it as a means to pulling the heat in, because put your hand to the back of that. Cold, isn't it? Okay?
Yep.
All right? That's ice cold. What I want you to do. Here's what I want you to do. Okay, you got to follow this clear. Only do a voltage drop on VD1 and VD2. And by the way, whatever you're going to call load 1, load 2, and load 3, you have to agree upon yourselves, amongst yourselves, whether it's going to be, you know, load 1, 2, and 3, or whether it's going to be 1, 2, or 3, or whatever you do. And however you agree, you have to stay with that agreement till we're done tomorrow, whenever we're done. Okay, you can't change horses in the middle of the stream by calling this 1, 2, and 3 and then taking measurements and measuring 1, 2, and 3. It's going to screw you up. So however you want to go right to left, left to right, it doesn't matter.
There's three of us
You got
who
to
can
agree
actually have a good
now.
vote.
You have
Someone
to
will
agree now.
decide.
Okay.
They can't. They can argue.
Now, here's what I want you to do. Measure load 1 and load 2 voltage drops, but don't measure number 3. Don't measure it. Whichever one you're calling load 3, don't measure it. Just measure 1 and 2 only.
You want to measure 1?
Okay.
Measure 2, and I'll measure 3.
And then total those two up. So go ahead.
Well, you can
So
measure
voltage
one,
drop
measure one, I'll
1,
measure 2.
voltage drop 1, voltage drop 2.
Well, don't get a turn then.
You're gonna be 3 along.
Yeah.
Be 3 along. So where's number 1 and 2? Okay. So go here and here, write it down. Here and here, write it down, and then total them up.
Yeah, that's good. For B1.
So you're only gonna do 1 and 2 only. Do not do number 3.
I'll watch carefully.
Okay. 1 and 2 only, no 3.
So we got 8 across. And we told her, or was I?
Okay, got it. Okay, now total or add load 1 and load 2.
Just for kicks, go across here too.
Add them together.
Also now wire.
Load 1 and load 2, add them together.
Across those two. Just for kicks, just to see if it.
There's a difference.
Okay, just don't do anything with number 3 yet. Don't do anything with
Just a
number 3
little
yet.
bit. Just a little bit.
Okay. Okay. Total out 1 and 2 and add them together. Now, take the sum of load 1 and load 2 and subtract it from your source voltage. Take the sum of load 1 and load 2 and subtract it from your source voltage. Okay? And whatever number that you get, measure R3 and see if that number lines up.
What do you guys think of the bar? 1384.
Yeah, 1394 minus the 954 came out at 440, and then this is calculated, and that's measured. It's 425. So we're
Fractional amounts are so what do you guys find?
very close.
Here on 3. And what was your, and that was measured?
What'd you guys
or
get?
calculated?
4.57.
Calculated. It came out perfect. Okay. All right. Excellent.
Hey, do you have later on?
So
Yeah,
we're what,
Yeah, absolutely.
3, 7,
Yes, sir, I am.
7/100ths of a volt
Okay,
out.
so what did you find out?
7/100ths of a volt.
Okay.
That's taking the voltage.
Now that we've taken some of the resistance and changed it in the circuit, you're going to see, you know, that we have a tall bulb that, you know, is barely lit, and so forth. So let me ask you a question before you measure it or whatever. Let me ask you guys a critical thinking skill question here a minute. Okay, here comes a critical thinking skill question. When you look at the little light bulbs, they're pretty bright. When you look at the tall bulb and it's dimmer, right? Which one of those bulbs has the higher resistance without even measuring?